Okay, this should be fairly easy. Find the eigenvalues and eigenspaces of this 2x2 matrix.
I will define the characteristic polynomial as the determinant of lambda times the identity matrix minus the original matrix. Recall that you retrieve the eigenvalues when this function equals 0.
I outline all the steps in my computation, but the audience should know that anything multiplied by the identity matrix results in values along the main diagonal.
Thanks, Joe. We can now compute the determinant. Since this is a 2x2 matrix, the computation is straightforward.
There is a repeated eigenvalue with an algebraic multiplicity of 2. We can find the eigenvectors of the non-zero solutions of the following linear system.
We have two free variables. When a column does not have a leading entry, it is a free space, hence free variable. It should be noted that this equation is satisfied for any value of x1 and x2. These values are scalars that can be arbitrarily chosen.
The eigenspace of eigenvalue 1 spans our two linearly independent vectors. Hence, the dimension of the eigenspace is 2. Correspondingly, the geometric multiplicity of eigenvalue 1 is equal to 2.
Do the algebraic and geometric multiplicity of an eigenvalue always coincide?
No, they can differ. The geometric multiplicity can never exceed the algebraic multiplicity. It should be known that a matrix is diagonalizable if and only if these two multiplicities of each eigenvalue are equal. Donald, do not mislead our audience.